Hi everyone, this is Fahad Mirza and I welcome you to my channel. I have no doubt in my mind that if you are looking to implement AI in your production environment, in your company, you have to have retrieval augmented generation or RAG. Because as long as you don't provide your own company's data to these LLMs, you won't be able to extract the intelligence which is tailored to your own use case. Just having a chatbot to chat with your documents or to generate images or logos, that really doesn't cut it. The amount of investment, the amount of effort, the amount of hype around this AI demands us to implement RAG. RAG is a feature technology framework which enables us to provide more grounded context of our own data to these large language models. Just to give you a very simple example, for example, just take the example of Llama 70 billion. These models, they are not aware who Fahad Mirza is because they haven't been trained on my personal information or my company's information because my company's documents are private. They don't really know about it. Now, whenever a person asks these models a question about myself, my personal information, either these models are going to just refuse to answer because they don't know, or they would hallucinate, which means that they will fabricate the response. That is where RAG comes in. RAG enables us to provide this data to these models without the need of retraining them or fine tuning those models on our data. The way at a very high level this RAG works is that, for instance, you have your own data scattered throughout PDF documents. You take those PDF documents, you divide them into smaller parts which are called as chunks, and this process is called as chunking. Once you have chunked those documents, you convert them into a numerical representation with the help of a embedding model, and then those documents or those numerical data get stored in the vector stored, and from there an index is created, and then whenever a user asks a query about it, then a similarity search is done, and then maybe a re-ranker model ranks the responses, gives the most similar result back which is appended to the user's question, and then that combined stuff, the user prompt and the return data from your vector store, is given to the model so that model understand the whole context of that data, and then by using its own intelligence, language prowess, model returns you the answer. So that is the whole idea of this RAG pipeline. Now the problem starts happening is that whenever you, the first step, the pre-processing, which is the chunking, that whenever you have a lot of data and you're trying to chunk it, you really don't know how to chunk it, right? I mean, because do you chunk it page by page? Do you chunk it line by line? If you have millions and millions of documents, how do you chunk it? So in this video, these people have tried to fix that or try to address this issue. I don't think so that they have been fully able to do that, but still I believe what they have done is quite interesting, and this could be a foundation of future work on improving this chunking more. So they have introduced a new chunking strategy developed by ZeroEntropy for general semantic chunking using Llama 70 billion. Because this is a major issue with building RAG pipelines, you have to do a lot of experimentation and tuning to get it right. Few documents doing RAG, that is all good, but when you have, as I said, humongous amount of data scattered throughout your data stores, then it becomes a real pain. So how do you chunk it? For example, as I mentioned earlier, if you want to address that you have hundreds of thousands of documents, how do you use the chunking to highest faithfulness of the retrieval of your data while also maximizing the signal to ratio of the retrieved chunks? And there are a lot of chunking strategies already in the market. For example, we have naive chunk, which uses fixed size chunks of varying length with varying overlap ratio. We have semantic chunking, where embedding similarity based chunks happen with on the basis of some thresholds. And then we have this Llama-Chunk, which is a prompt-based chunks created by Llama 70 billion. So what happens is that for the Llama-Chunk, they output the log props to chunk at a certain level of the document. Let me explain in a simple words. You see on your screen, we have this snippet from US Constitution, and we want to chunk it. And this is section 1, section 2. Now how do we chunk it? One simple way is to just chunk it section by section. Section 1 is a one chunk, section 2 is another chunk, but you see it could be of varying length. So this is one strategy. Another strategy will be to just randomly chunk it on the basis. So sorry, this is chunk 1, chunk 2, chunk 3. So section by section, line by line, or just at the random places. So you see these chunks doesn't really make sense. There are 3 chunks of this, but what we have done here, is it section by section, line by line? You really don't know. Maybe a random stuff. And it says that it completely destroys the ability to understand the content of the document, because maybe there is some overlap, there is some repetition. So I hope that you get the point, and it is quite confusing. This is where Llama-Chunk algorithm comes in. It's very simple. What it does is it just picks a special token such as this Chinese word, just a special token, and then it puts this token in this text randomly wherever you want to chunk it. So for example, this is one chunk, and then from here to rest of it is the second chunk, and then you this is one chunk, this is one chunk, this is one chunk. So by just putting it one character, then you can simply chunk it. Now the real question arises, how do you know where exactly to put this? This is where their algorithm works, and if you look here, they have inserted it here, and that is the whole idea behind this llama chunking. So now what they have done is that they have used log probes in order to address it. First, let's understand what is log probe. Log probe is short for log probability. It's a measure of probability of an event occurring expressed as a logarithm. And what Llama-Chunk is doing, it is using log probe to represent the likelihood of chunking at a particular point in the document. So it is taking a document as input. It is using Llama 70 billion model to generate prompt based chunks as we saw above, and in this one too, where it is using this red where that special token is, and then it is outputting log probabilities for each chunking solution. So Llama 70 billion analyzes those, and then very intelligently we are using a model like 70 billion llama to put those special tokens in our document, and this is decided by model on the basis of these log probes. So we don't have to worry about it. We just tell it that use this algorithm, and then use llama 70 billion, which is a very good model, to intelligently place that special token in our text, and then the text is chunked on the basis of that special token. And then there are a lot of caveats there, a lot of stuff. For example, they have shown that, for example, this is a split by character position, this is again log probe split, which is more even. So, and there are a lot of other things and examples which they have shown that, okay, what would happen if you use Python, what would happen if you use markdown, HTML, legal text, and then they have discussed some of the benchmarks here. So pretty interesting one. Now the one downside is that they have shared the code if you go to their repo, but you really don't know how to use it. That is a problem. They have tried to use some of the 70 billion. For example, if I take you above, there are some installation script, I have tried it out, but it doesn't work. So I think it will be a good idea. That the idea is great, but it will be really good to have some instructions as how to run it. Maybe we could use our own data. That will be amazing. But anyway, I believe that chunking is a real pain point if you are doing it in production environment, and we need more projects like these, to make it easier, to make it more, I would say, production worthy. But it would be really good idea that now it should move out of research, and we should see some sort of tooling around it. So that's it. I will drop the link to it in video's description. Let me know what you think. If you want to learn more about RAG, please search on my channel. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network, as it helps a lot. Thank you for watching.